Hey everyone, it's me, Miss B. And in today's video, we are looking at the practice problems for Unit 2, Lesson 10 of Illustrative Math Algebra 1. So let's hop right in and see where we're at. This lesson was about connecting equations to their graphs. So we're going to be using and getting a lot of information from graphs in this practice assignment. So Andre bought a new bag of cat food, and the next day he opened it to feed his cat. The graph shows how many ounces were left in the bag on the days after it was bought. So, well, he gets a bag of cat food, he's feeding his cat from it every day, and then we're graphing how much he has left. So the first thing they're asking us here is how many ounces of food were in the bag 12 days after Andre bought it. So 12 days after. So we have a lovely labeled for us down here in the bottom is days since the bag was bought or opened. So we're going to look for 12 and then follow that up to our graph and put a point and try to figure out how much was there based on our graph. So we're going to use some numbers. This one looks about halfway. So from 12, halfway between 40 and 32. So I'm going to put a dot right here just to represent where I'm looking at for this information. Halfway between 40 and 32, that's 8 spaces. So this is going to be 36. So we would say 36 ounces. And that's what we're going to say is left in that bag. So we find 12, and we look up to find this, then we read over to find the amount. How many days did it take for the bag to contain 16 ounces of food? So we're starting now with 16 ounces, and then they're asking us how many days. So we're going to start at 16, go this way to find a point on our graph, which meets nicely at a corner, and find that our answer here is going to be 24. So we would say 24 days. Question C asks, how much did the bag weigh before it was opened? So before it was opened is going to mean kind of basically our initial value. So before it was opened, for us, that's going to mean day 0. So I'm going to write here day 0. And that looks like it is our y-intercept, which is 56. So we're going to say 56 ounces. And then question D says, how many days did it take for the bag to be empty? So the bag to be empty means we're looking for 0 ounces, and ounces is abbreviated OZ. I'm not going to write the whole word out. And that looks like it is right here. So this is partway in between 32 and 36. So 33, 34, 35, 36. There's about 4 spaces in between these. So 32, actually, so 33, 34, 35. We can say around 33. So approximately 33. Around 33 days. Because it doesn't land at a nice even spot, and it does ask us about how many. So that does mean we can give an estimate, and that will be okay. And that's our first question. Just really looking at linear functions and then how they relate to the actual graphs, and then getting that information from those graphs. So let's move to question 2. Question 2, we have a Little League baseball team, and they are ordering hats. Oops. This graph shows the relationship between the total cost and the number of hats. So you'll see we have total cost on the left. That's our vertical or our Y. and then the number of hats that they order is on the horizontal or the x-axis. The first thing that they're asking is right over here. What does the slope of the graph tell us in this situation? So they didn't have this labeled as like A, B, C, or D. So we are going to answer this still right underneath it. And then, oh, actually, I'm sorry. I was misinterpreting A, B, C, and D as parts or options, but this is multiple choice. So what does the slope of the graph tell us? Well, before I go analyzing my slope, we're going to look at where things are at on the graph. So I did just say that the total cost was on y, and I know that slope is rise or your y's over run or your x's. So the slope here, not numbers, but just what we're measuring on those is total cost divided by number of hats ordered. So total cost divided by hats ordered. And sometimes the way I read this line in between that is maybe as like per. So the slope here might represent for us the cost per hat that they order or per additional hat. So let's actually read our options now and see what we have. So option A says it tells us there's a fixed cost of approximately $35 for ordering hats. That may be true, but that's not what the slope is telling us. That would be maybe what the y-intercept tells us. So not this one. With a thicker marker, not that one. B says it tells us the amount that the total cost increases for each additional hat ordered. That's a possibility. C says it tells us that when 9 hats are ordered, the total cost is approximately $160. Well, the slope isn't telling us an exact coordinate pair, so it's not going to be that one. And D says it tells us that when the number of hats ordered increases by 10, the total cost increases by approximately $175. That may also be true, but we don't necessarily need to know the exact number, so I am going to choose B as my answer here. The slope will tell us the amount that the cost is going to increase for each additional hat that they order. So we're going to cross out D. And B is going to be our answer, so because it's the cost per hat, so the cost for each is another way that we can kind of represent the word per. If you think about the phrase like miles per gallon, that's the amount of miles you can go for each gallon of gas that you use. So per and for each, same idea. And so yeah, that kind of works out with what we had, or what I had mentioned beforehand. And that's going to bring us then down to question 4. So a kindergarten teacher bought $21 worth of stickers and cardstock for his class. The stickers cost $1.50 a sheet, and the cardstock costs $3.50 per pack. The equation, 1.5s plus 3.5c equals 21, represents the relationship between sheets of stickers S, packs of cardstock C, and the dollar amount that the teacher spent on these supplies. Explain how we can tell that this graph represents the given equation. Okay, so to start with, we can use our intercepts. So that's actually what B is going to ask us, but we can tell because it's linear. We can also tell that it maybe has the correct intercepts. And then we can also tell by plugging in the order pair. So explain how we can tell. I would say that we would like check. So we can tell. We can tell by plugging zoom out a little so I have space to write. We can tell by plugging the ordered pairs into the given equation. So since they give us some ordered pairs on this graph, we can plug those into the given equation and check that they work. And if it's linear and they work, then we know it's the correct equation. So I'm going to leave that one there as that explanation because we're going to continue to actually talk about B, which is another way we can tell. We're going to say, what do the vertical and horizontal intercepts mean in this situation? So let's go one by one. 0, 6 means he bought. Now we're going to have 0 of one type of item and 6 of the other. So on our horizontal axis, that's sheets of stickers. That's our X value of 0. So he's going to have purchased 0 sheets of stickers and 6 packs of cardstock. So means he bought 0 sheets of stickers and 6 packs of cardstock. Okay. And then I'm going to write in red for the other one, 14, 0. So 14, 0 means he bought 14 packs. Oh, I'm sorry, sheets of stickers. Not packs, sheets. Sheets of stickers and 0 packs of cardstock. Okay. Now, technically, it doesn't mean that he bought those. It means those are potentials that this teacher could have purchased for his classroom. So he could have bought with those $21, he could have purchased only 6 packs of cardstock or only 14 sheets of stickers. And that's going to be it for our front page. So let's flip over to the next page and keep going. And then actually, let's see. Yeah, we do have a third page on this one, so we will get through these kind of as quickly as we can. Now the numbers are a little funky. I do realize that this is 1, 2, and then 4, and then we're going to skip back and go to number 3. That's just to help them fit on less pages, because otherwise 3 was too big to fit at the bottom there. So they're a little out of order, but honestly, they're fine in terms of what we're actually doing. We're doing the same questions, we're just slightly out of order. So for question 3, a group of hikers is progressing steadily along an uphill trail, and the graph shows their elevation or their height above sea level in feet at each distance from the start of the trail in miles. So they're hiking up an uphill trail, and then as they go along the trail in miles, this graph is going to show us how high up they're climbing. So what is the slope of the graph? And show your reasoning. That is the first question. So I'm going to use the graph to actually answer that. And I'll start with red. And I just want to identify 2 points that are on what I would call corners of, but they're really just where it looks like the graph squares kind of meet. So I'm going to use these 2 right here. And I'm going to say that for boxes, this goes up 1, and then it goes over 2. But the values here are different they're not 1 and 2. This is one box, but this increases by 500 because we go from 1,500 to 2,000. And then along the horizontal, we have to check what the scale is there, and in this case, it is just going to be 2. So we are going to say 500 over 2, because we always do up and down over the horizontal, so it's always rise over run or y over x. Um, 500 over 2 is going to be 250 as our slope. And this would be like C graph for more of my reasoning, at least. Okay, so now what does the slope actually tell us? What does that 250 mean? Well, it's 250 over 1, and the vertical is elevation, and the horizontal is miles. So this would be 250 feet of elevation. So they're gaining, so it's positive. So I'm going to actually write this as a sentence. The hikers gain 250 feet of elevation per mile that they hike. Okay. Now, part C says write an equation that represents the relationship between their distance from the start of the trail, so x, and their elevation, y. So in order to do that, the easiest way, especially to read from a graph like this, is to use slope-intercept form. So I am going to say y equals mx plus b. I already found the slope from the previous question, so now I'm going to go back and identify on here what their vertical intercept is, or their y-intercept, and that's going to be 0, 500. So we have that m was the 250, and that the y-intercept is 0, 500. So we're just going to use the 500 part of that. So we'll say y is equal to 250 x plus 500. The 500 functions as sort of like our initial value, which is what we called it when we were doing our exponentials unit. So initial value, vertical intercept, y-intercept, all the same things here. It's what we're starting out at. So at the beginning of their trail, they have 500 feet of elevation. So the next question, or the next part of this question here, is does the equation y minus 250x equal 500 represent the same relationship between distance from start of the trail and the elevation? And then explain your reasoning. So basically, is this an equivalent equation? If I said, is it the same equation? It's slightly different. But is it equivalent? The answer to that is going to be yes. We are going to say yes, yes, it is an equivalent equation. Um, and we can say it's an equivalent equation, and then we'll just put a period here, sorry. And then we will say 250x has been subtracted from both sides, just to show that we know it's that it's a valid move or a balanced move. Has been subtracted from both sides. There we go. And that's going to be it for question 3. And since we've already done question 4, which was on the previous side of our page here, now we're on to question 5. In physics, the equation PV equals nRT is called the ideal gas law, and it's used to approximate the behavior of many gases under different conditions. P, V, and T represent pressure, volume, and temperature, and N represents the number of moles of gas, and then R is a constant for the ideal gas. Here they're asking us which equation is solved for T. Well, if it is solved for T, that means T needs to be by itself. We should have T equals, or something equals T. So right away, we can say it's not A because T is not by itself. It has an N next to it. Now the next 3 do all have T by itself, but we need to know which ones are accurate, or in this case, like which ones are true for solving this for T. So we're going to go back up here and look at this function. And I want to point out that T is right here. And one of the first things I normally like to do is just identify where is the variable I am trying to isolate, because then I can see what else is surrounding it that I have to deal with. And in this case, that's going to be N and R. These two are both being multiplied with T. So to undo that, we should divide both sides by N and R. And C has us subtracting N and R, so that's not correct. D had us multiply both sides by N and R, so that's also not correct. B here is correct because we have both sides divided by N and R. So our answer is B. And then that's going to bring us down to question 6. And then we'll have, I think, 1 or 2 questions on the next page. 8, 9, 10. I'm sorry, we have 3 questions on the next page, but it's okay. We'll get through it together. So question 6, to raise funds for uniforms and travel expenses, the soccer team is holding a car wash in a part of town with a lot of car and truck traffic. The team spent $90 on supplies like sponges and soap, and they plan to charge $10 per car and $20 per truck. And their goal is to raise $460. So we're now going to answer A, B, C, D, and E for how many cars do they have to wash if they wash the following number of trucks. So they want to raise $460. They're charging a certain amount, but they already spent $90. So we want to include that $90 as negative money because we want their car wash to pay that back and raise the 460. So we will say here that they are charging, we'll use C for cars and T for trucks. So $10 per car and $20 per truck. We would normally say we want that to equal the 460. Oops, that's a 460. But they already spent $90 to get some of that money. So we can plug in and find how many cars they would have to wash if they wash the following number of trucks. So this would be 10C plus, now in this case, T is 4, so 20 times 4 is going to be 80 minus 90 equals 460. We are going to, 80 minus 90 is negative 10, so we'll have 10C minus 10 equals 460. Add that 10 to both sides. You would get 10C equals 470. So C is 47 cars. Now, that's kind of a lot of work to show, especially for a very small area that we have here to actually do some of this work. So I'm going to skip ahead a little bit and jump to T number of trucks. And in that case, solving for C, which is really what this is asking us to do, is going to give us an equation where we can just plug in some numbers for B, C, D, and E. Now, the other trade-off is that for every car, trucks are twice as much. So you can do a little bit of arithmetic here if you know the number of cars and the number of trucks. It's not a one-to-one trade-off. So there's a little bit of algebra you can do, calculating there with some arithmetic, but I think it's going to be easier if we start with E. So I'm going to say if I had 10C plus 20T minus 90 equals 460. Let's add that 90 to both sides. So 10C plus 20T is going to be equal to 90 is going to put this at 550. Then from here, we would want to subtract the 20T. So we would have 10C, subtract the 20 from both sides. We would have 550 minus 20T. And then we would divide everything or both sides here by 10. So C would be equal to, and both of these do divide by 10 if we just remove the zeros attached to each of them. So this would be 55 minus 2T. And from here, we can find all those numbers of cars. So we can do 55 minus 2 times 15. And we can do 55 minus 2 times 21. And we can do 55 minus 2 times 27. And I will put a box around this one because this was my kind of formula down here. And then I did have an answer up here for cars. So now let's plug the rest of these just into a calculator. For B, this is going to be 55 minus 30. So we should get 25. 25. 25 cars. For C, we're going to do, I don't know if I called the last one C or not. It's B. I feel like as I said C this time, I was like, didn't I just call the last one that? But either way, this is going to be 55 minus 42. So that'll be 13. So we can say 13 cars. And then 2 times 27 is going to be 54. So 55 minus 54 is going to be 1 car. So this would be if everything was a truck, they would need one last car to finish it off. So yeah, it's a little easier once everything is solved for C. And that's why we've emphasized solving for a specific variable, and sometimes they will phrase that question as maybe which question or which equation would make it easier to solve or to find the number of cars. So that's another one of those sort of code words that when they put that in a question, it means solve for. Okay, so that's going to take us on to our third page here, where we have 3 more questions. There is not a number 7. There is just 8, 9, and 10. So I know that we went from 6, now we're going right to 8. So just make sure you're not missing anything. There is not a number 7 on this. Okay, for number 8, explain why the equation 2 times 3x minus 5 is equal to 6x plus 8 has no solutions. Okay, let's multiply this one out, and I'll show you through the work, and then we can write a sentence. So let's distribute this part here. So this would be 6x minus 10 is equal to 6x plus 8. Now, we want to get all of our variables together and then all of our numbers together. So let's subtract 6x from both sides here. So when we subtract 6x, this goes away. And when we subtract 6x, this will also result in 0x, or essentially it going away. So what we're left with is negative 10 is equal to 8. Because we can say this is a false statement. So I would say false, meaning no solution. So I can describe this as all of the variables now they kind of canceled, they disappeared. All of the variable terms canceled out and leaves, oh, and left, have some tense agreement here, so and left a false statement. This means no number plugged in for x could make this equation true. So what that means is basically like, hey, if I tried to plug something in here for x, those numbers are essentially just going to cancel out and disappear. And nothing is ever going to change that negative 10 and positive 8 and make them equal to each other. I could put in whatever number I want and it's never going to happen. So that would make it no solution. That's then going to bring us down to question 9. Consider the equation 3a plus 0.1n equals 123. If we solve this equation for n, which equation would result? So first of all, we want to have just n by itself, no coefficients or anything. So solve this equation for n means n equal to something. So we're not going to have a because n is not by itself. Now let's look at the rest of what we have here. So we would have to start with the 123 and subtract the 3a. So we are going to have something subtracted, and you kind of see that in each piece. You see the 123 minus that 3a, and in this case they have an extra 0 on the end, or here they're divided by 0.1. We're definitely not going to subtract the 0.1 that's attached to the n because that's attached to n through multiplication. So while this is the first step, we say this is step number 1, we then need to divide everything by 0.1. So that's actually going to rule out option D, even though we have it divided by 0.1, because we don't have 123 minus 3a. They reverse the subtraction, which makes it not true. These would need to be switched in order. So D is not true because of that. That's going to leave our only option as C. And you're like, but why don't have anything on the right-hand side that's divided by 0.1? Dividing by 0.1 is the same as multiplying everything by 10. So they did actually divide everything by 0.1 by adding the 0 onto each of these terms. So we will select this one, and then we can say divide by 0.1 is equal to multiply by 10. And that's because 0.1 is 1/10, and it's the same as multiplying by the reciprocal, which is 10 over 1. That is then going to bring us to the very last question here. So, Diego is buying shrimp and rice to make dinner. Shrimp costs $6.20 per pound, and rice costs $1.25 per pound. Diego spent $10.55 buying shrimp and rice. The relationship between pounds of shrimp S and pounds of rice R and the total cost is represented by the equation 6.20 S plus 1.25 R equals 10.55. We want to write an equation that makes it easy to find the number of pounds of rice if we know the pounds of shrimp purchased. So when they say makes it easy to find the number of pounds of rice, we know makes it easy to find means solve for, and then rice means R. So we're going to solve for R. So we're just going to start with the equation they gave us and solve that for R. So 6.20 S plus 1.25 R equals 10.55. Well, the first thing I see here is that I have a bunch of decimals all over the place because I'm using dollars and cents. What I prefer to do, and if you don't prefer to do it, you actually don't really have to. You can leave everything here with decimals and just subtract these, but I prefer to work with whole numbers. So in order to move that decimal point 2 places for each and every term here, I am going to multiply this entire thing by 100. So everything on the left, multiply by 100, and everything on the right is going to multiply by 100. All that's going to do is create 620 S plus 125 R equals 1055. And that's if we had the equation in cents instead of dollars, this is what it would be. So we want to solve for R, which means I would like to get R now by itself. In order to do that, I want to move away any other terms first. So we're going to subtract 620S from both sides. That will leave me with 125R equals 1055 minus 620S. And then R has a coefficient attached to it, so we want to divide everything by that coefficient. So divide everything by 125. Now, I don't think 125 is going to go evenly into each of these, but we're going to try to reduce these if we can. I know that everything at least here should be able to divide by 5. So if we did 1055 over 125, that can definitely reduce. I think we can reduce that by 5. And 620 over 125, the same thing. Yeah, we can divide everything here by 5, and I think that's going to be the largest number that we can. So on the left-hand side, everything disappears here except for R, and we have R. And then on the right, we're going to reduce this by dividing everything by 5. So including the numerator and the denominator, meaning 125 divided by 5 is 25. And then 1055, when we divide that by 5, we will get 211. And then 620, when we divide that by 5, we will get 124. So 124s. And this, you could have maybe 2.11 instead. And that cut right through my equation. I don't want that. I want it to go up here. And like that. There we go. So yeah, you could have this with some decimals and stuff involved, but I don't like to have decimals in my denominators and everything like that. I like to use whole numbers. So this is what I would use for this equation. And I believe that is our last question for this assignment. So thank you for sticking with me through it. Hopefully my explanations helped you out a little bit if you were stuck. And don't forget to always ask your teacher for help in class if you need more explanation, or if you think I did something wrong. So again, this has been the Unit 2 Lesson 10 practice problems for Illustrative Math Algebra 1.